Hi everyone, it's Sorkin. Today we have a problem when we are given an array of integer which represents the daily temperatures, and we need to find for each day how many days we should wait before having warmer temperature. For example, in this case we need to wait 1 day because the next day is warmer than the first one, so 0 index, first index, second, and so on, right? So the first one is more than first 0, so the first day, so that's why we need to wait 1 day. For the 74 is the same, next day is warmer, then we have to wait 1 day. But how about for the 75? For 75 the next warmer day is 1, 2, 3, 4, because all other, so the next one 71, 69 and 72 is less than 75, so we need to wait 4 days before having warmer day. And also by the requirement, if it's not possible to have a warmer day, then in that case we are setting the values to 0 here. So for example, for 76 there is no possibility that we will have warmer day, and the same for 73. So how we're going to solve this problem? The first approach that comes to mind is to, for every day, just to find out that whatever is the warmer day, right? So for example, we find for the 71, then we go and we find for the 74, then we find for 75, then for 71 we are going and for checking each element and finding the next greater element, right? And taking the index of it minus our index of our current day temperature. But in this case, the time complexity of this solution is n squared. Can we do that with the n? Can we reduce our time complexity? Yes, we can. So we can use, in this case, we are going to use a stack, but we are going to use a specific form of the stack is a monotonic stack. In the monotonic stack, the values that we put in the stack, they are either increasing, monotonically increasing, or they are monotonically decreasing. So that's the approach that we are going to use here. Okay, let's take this example and work on it. Let's say we have this array, right? And with the 0 index, first, second, third, 4, 5, 6, and 7. So what we are going to do, we are going to create an array of integers with the same size as our days, number of days, and we are going to set for each one how many days it will take for each day to have a next warmer day. So for example, and we are going to solve it using the monotonic stack. So let's create our stack here. So this is our stack. First thing that what we are going to do, we are going to start from the end of our array, for example from the 73, right? And we are going to add, so our array, our stack, so values in our stack should be monotonously decreasing. So for example, first we are adding 7, the index of 73, right? So, and we are checking if our stack is empty, it means that there is no element that is greater than our 73. So there is no element actually. So in that case, we are just setting this value to 0, right? So there won't be any days that is warmer than 73. So, and we are adding 7 to our stack. So we are adding 7, the index, to our stack. Let's go to the next day. Next day is 76, right? We are adding 6 to our stack. But before adding that, our stack should be monotonously decreasing, right? 76 is more than 73. So it means that we need to take this 7 out of our stack, right? And we need to add our 6 here. So we are adding our 6 here, we are adding our 6 here, and we are adding our 6, and we are setting the value to 0 here because there is no day, so there won't be any day that is warmer than 76. Let's go to the next one, 72, right? 72 is less than 76, so we are adding an index of it to our stack. So we are adding here 5, right? So, and we are setting that to, so how many values do we have in this stack? Only 1, right? So we are adding 1 here. So we are adding 1 here, so which means that we need to wait 1 day to have a warmer day. So let's go to the next one, 69. So how about the 69? 69 is less than 72, so we are adding that here. So we are adding that here, the index of 4, and again we are setting the value to 1, right? So we are adding the value to 1. So how then let's go to the next one. So the next one is 71. 71 is less than 71 is more than 69. Then in that case, what we need to do, we need to take from our stack, we need to take the values from our stack until our value is less than the value that is in the stack. So for example, in this case, we are taking 4, right? We are taking 4 because 69 is less than 71. So how about 72? 72 is more than 71. So we are adding 4 here. We are adding 3 here to our stack, and we are setting the value of 71 to 2, right? Because we need to wait 2 days to have the warmer temperature. So now let's go to the next one, 75. How about the 75? 75 is less than 75 is more than 71, is more than 69, and is more than 72. It only less than 76, right? So which means that we need to take all this value from our stack. We are going to take all this value from our stack until we have the value in the stack that is until we have a value in the stack that is more than our current value, right? So we are adding the index here, which is 2, right? And how many, so what's the difference between 75 and the next one, right? 6 minus 2 gives us 4, right? We are adding here 4, right? And then now we are going to the next element. The next element is 74, right? 74. We are adding that to our stack. We are adding that to our stack index of 1 and setting that to 1. The same is 73. 73 is less than 74. So we are adding 0. We are adding 0 here and setting that to 1. Now we have our result, right? Which we did in one pass. And time complexity is n. But the downside of it that we used extra space. So our space complexity, in the worst case, we are going to add to our stack all elements. So our space complexity is also going to be n. So as you can see here, we have monotonously decreasing stack. So 76, 2 is 75, 74, and the 73. If we are maintaining the monotonously decreasing stack, so in other problems, for example, we can use monotonously increasing stack, then we can solve this problem with the linear time complexity. Okay, first thing that we are going to do, we are going to create an array of integers. Let's call it result, and it's a new int array, right? And it's the same size of our temperatures length. Okay, so now we need to create a stack where we are going to add our elements, right? So we are creating a stack of integers. Let's just call it a stack, and it's a new stack. So we created our stack. So what we are going to do, we are going to start from the end of our temperatures, right? From end of our array. So for that, I is temperatures length, right? Length minus 1. Where I is more than or equals to 0, and we are decrementing I. So we are starting from the end of the array. What's the first thing that we are doing? We are going to check that if we are going to do that in while loop. While our stack is not empty, while it's not empty, and the next condition is if our current element, right? So temperatures I, if it is less than or equal to, because again we are creating here monotonous stack, monotonously decreasing stack. So so the next element should be less than or equal to, so should be less than of the element that we have in the stack, right? If it's more than or equal to our whatever we have in the stack, right? Stack, we need to pick here. So we are not actually taking element, we are just checking it. So if it's while it's more than our whatever we have in the stack, so which means that we need to take from our stack the element until our stack is empty, right? Or we find the next element next the greater temperature. So stack, we are popping from our stack, right? So we are popping from our stack, we are taking from our stack. So, and the next one, so we are going to check if our stack is empty. So what's that mean? It means that we cannot have, there is no next element that is greater than our current value. So there is no warmer day, right? So there is no warmer day for the current day. So in that case, we are setting the result I, we are setting that to 0, right? And if it's not else, what we are doing here, we are setting our result I, to whatever index we have, right? Stack pick, right? And minus our I. So for example, let's say that the next day is the next warmer day is 6, and the 6 minus 2, so our current index is 2, 6 minus 2 gives us 4. We need to wait 4 days before the next warmer day, right? So after that, we are adding to our stack, we are pushing our current index, I. Okay, that's it. And at the end, we are returning our result. So we are returning our result. Okay, let's run it. Okay, we forgot to add here. So we are comparing the temperatures, right? So let's add here the temperatures. Let's run it one more time. Okay, great. It works as expected. Let's calculate our time and space complexity. As we said, we are solving this problem in one pass, right? Our time complexity is linear, but also we have space complexity here. Our stack is in the worst case, it's gonna have n elements. So our space complexity also of n. Okay, that's it. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.